start by introducing myself as this load. So I'm Pedro Bachet. You probably know me. I've been around for a few years already. I've been working on the performance stuff, on the architecture for the performance POC, the reference architecture, and lately on the vNext implementation, which is the direct implementation of vNext. And now I'm working for the Interledger Foundation. Jason.
Well, yes, I'm Jason Brewer. I mostly contribute to settlements, but also helping out Pedro with the performance testing and the TigerBeetle integration work, also from the Interledger Foundation.
All right, cool. Thank you, Jason. Okay, so the agenda today is two topics. First, we're going to talk a bit about the architectural approach for the TigerBeetle integration and the accounts and balances. And then Jason's going to walk us through the mechanics of how we check liquidity during the transfer, the Mojaloop transfer. There's quite a few interesting things there. So first, regarding the accounts and balances, we need to give a bit of a primer before we dive deep in how this works. This is obviously in the context of Mojaloop vNext, which is a future version of Mojaloop with a different architectural principle, exactly the same Mojaloop. The principle is that we have bounded context. So we have different areas of the system that are responsible for the different business logic for each of its parts. And we have things like the participants lifecycle management. We have things like quoting, settlements, account lookup, for example. And one of the parts that we have, which is also separated from the others, is the accounts and balances. So in essence, what accounts and balances is a ledger abstraction. It means that other parts of the system, participants, transfers, settlements, for example, they talk to the ledger abstraction. So basically they say, create an account, give me the balance of an account, create entries on an account, and they use this in a directed way. And by that, we mean they don't participate in the usual event-driven saga approach that we have for the rest of the system, which we do it for performance reasons. In here, we use it in a synchronous mechanism in a directed way so that we can guarantee the consistency of the changes in the accounts. And essentially, whenever we make a change in an account, a journal entry, it's recorded, it's immutable, it's not going to change. And the other part is there's the usual benefit of an abstraction that no one else knows how the abstraction actually works. So what's inside accounts and balances, the other parts, they don't know. They just have a contract to it. So what is it composed of? There's three main parts. One is the chart of accounts service. And obviously all of these services are multiple instances. The chart of account service exists to map the accounts. So the internal accounts in Mojaloop, so a payer position account or a participant position account or a liquidity account has an internal ID, and then it has an external ID. And that external ID is the one that belongs to the concrete ledger implementation. So the chart of account service has one very important function to hold that map between the identifier of an account inside Mojaloop and in the ledger implementation, and also the account metadata. So the life cycle and the state of the account. Is it active? Is it not active? Is it a liquidity account? Is it a position account? And so on. Then we have the concrete ledger implementation. So this is actually where the accounts live from the accounting perspective. And this basically has accounts and journal entries. This is the only place where we store balances. And this is the part that really needs to be atomic in the sense that if we create a journal entry that is immutable, that's going to affect the balance, that's from the concrete ledger implementation that we read the balance from. And then we have the client lib, which is essentially a nice to have so that other clients, other parts of the system can simply use a nice library to call the accounts and balances and to just use its functions. And this is part of the strategy that we have all around vNext for all bounded contexts that provide services to other bounded contexts. We provide a client with it so that the other bounded context can just simply use the services, in this case, in the accounts and balances. So what does that mean? So we have three types of functions in that abstraction. We have management functions. There's other details in here. We're going to present only the most important things. So things like create an account, for example. whenever we create an account, we have to go to the COA so that the COA can verify that the account can be created. It's not duplicate. It has the right type of account. And then the COA is responsible for interacting with the ledger to make sure that that actual account in the ledger is created, mapping the IDs or keeping the ID map, and then returning a successful answer. We have the high performance batched requests. We have two types of requests, a high level and a low level. Both are batched so that we can have high performance, the maximum performance possible. I'm going to start by the simplest one, which is create journal entries. In here, we are just telling the accounts and balances, I have an account to credit or an account to debit and an account to credit, and here's the amount I want to do it. So there's an array of that. Please go and execute all of those entries, affecting the balance, obviously, and then at the end, return if that batch was successful. It's just create journal entries. We have another one, which is the most important one. And this is specific for transfers because it needs to map nicely to the abstraction that we have in our Mojaloop transfer with the two-phase transfer approach. And I'm going to detail that in the next few slides. Then at the bottom, we have the reads. Basically, there's a few other reads, but the essential ones are get accounts by IDs. Again, this is batched. This is a philosophy in here. We're maximizing the latency and the access that we have in the network. So you get a bunch of IDs for the accounts from the COA, and it's going to do the mapping and go to the ledger, get back the IDs, get back the account information, I'm sorry, with the balances. And again, this is important. The balances come only from the ledger, never from the COA. COA has no idea about balances. And we have another one, which is get me a list of the journal entries for that account so I can see which journal entries affected that account. So a bit more detail on what are the process high-level batch request types. I'm sorry for being very specific in here and showing a bit of code-like words, but I think this captures really nicely what we have in here. So we have in Mojaloop a preparation of a transfer, and we have the fulfillment of a transfer. And we have mapped those two main high-level parts of the flow of a transfer to two important requests: check liquidity and reserve, and then cancel reservation and commit. So these map nicely to do a prepare and then do a fulfill. The prepare makes sure that the payer has enough liquidity to proceed with the transfer. And if that is true, then it's going to reserve that amount from the position account of the payer. And this is atomic. Either it all passes or it all fails. And then the request goes back. There's a callback to the payee, and the payee has the option to accept that transfer. If the payee accepts the transfer, he's going to send a fulfill instruction or a fulfill request. And that fulfill request needs to do the reversal of the reservation and then committing the actual transfer. So basically what we do is that reservation is no longer there, unreserved. Let's put it like this: unreserve the funds, which means put the funds that we reserved back in the payer's position account, and then actually send those funds to the payee account. And again, these two actions are atomic. They either pass or fail, obviously, at once. There's a third one, which is the cancel reservation, which is reserved for anomalies, or for example, when a transfer times out before a fulfill, we will cancel the reservation, which is basically reversing the reservation. We will also cancel the reservation if, for example, the payee rejects the transfer. So going to the architectural, this first bit was just explaining how the thing works, and this is now more on the architectural level with the components. What we have is, on the left side, you will see the other bounded contexts, so the ones that actually call the accounts and balances for its functions. And you have the example with transfers, settlements, and participants. And the way the previous approach that we used was this proxied approach, which means that we have the COA in the middle as a service, and the clients that transfer, settlements, or participants used would always talk to the COA, and then the COA would do the transformation of the request, would do the mapping, and the COA knows which of the ledgers to use. We have As you know, our principle in the Mojaloop VNext is that we abstract all of the concepts, which means that we can have whatever ledgers we want to have in the future. Initially, we started with a very simple implementation of the built-in ledger, which we still have around. And obviously, the favored ledger is going to be TigerBeetle because it's going to be much more performant. So you're seeing two, but that's just for the sake of the example and to explain how things work. In reality, a deployment can only have one ledger implementation. So the way it works is the clients talk to the COA, and the COA talks to whatever ledger implementation we have. And the COA is responsible for the mapping, for the initial verification, for the state machine of the account, and then the response goes all the way back. Now, this has a few advantages and a few disadvantages. First, the client only knows how to talk to the COA. So that makes the client much simpler. There's no direct connection between the consumers or the clients and the ledger service. So they are not aware from the operations perspective, we can even hide the ledger from the network perspective. We can hide it, we can have it in a different place. The other benefit is that the COA can now decide to queue up and batch the request to TigerBeetle. So if we wanted to maximize the ability of TigerBeetle to batch, we can do this in the COA. The disadvantages, obviously, is there's one extra hop. So that means that we're serializing and deserializing, we're doing checks, and things will take a bit more time. And the COA service is now in the high performance path. And that's not obviously desired. Now, during the last convening, Jason and I were discussing this with Joran from TigerBeetle, and one of Joran's suggestions was, why don't you find a way to have the clients connecting directly to TigerBeetle in a control plane, data plane logic? That is exactly what we implemented. So what you're seeing here, this is a bit complex. I hope everything comes across as and is readable, but this is exactly the same set of components. But the difference, or the main difference now, is that the accounts and balances client starts by connecting to the COA service. It gets the list of the accounts that it needs. It gets all of the information that it needs to get, including the address of the ledger. So in the case of TigerBeetle, it's going to get the replica addresses for TigerBeetle. From that moment on, the accounts and balances client has that channel with the COA open. And this is a bidirectional channel, which means that the COA will inform the client if there's any changes in real time. For example, a new account or an account that was changed, etc. And what happens now is that if the client wants to send a transfer, for example, one of those high-level requests, or create an entry, it doesn't go through the COA service anymore. What it does is it goes directly to the TigerBeetle through that data plane. So this is a lot more efficient for the high-performance path. There's obviously disadvantages and advantages. So the principle is management and control goes through the control plane, through the COA, and then high performance data plane, data conversations, create an account, read an account and create entries is going to go through the data plane. Advantages is less hops, which decreases the latency, obviously. We no longer have the COA service in the high performance path. It needs to be there, but it's going to be less chatty. It's going to be requested services much less frequently. And the disadvantage is that now the client logic needs to know how to do all of this. So it's a lot more complex on the client, and which means changes to the ledger connection or TigerBeetle or the built-in will require changes to the client. The other thing is that if we have multiple clients, and remember, a VNext and also the current version Mojaloop as a whole is optimized to scale out, to scale horizontally, to accommodate for more load, which means that we have more instances of a service connecting to the ledger. This will obviously parallelize connections, but it has the adverse effect of reducing the batching, because now we have more services talking to the ledger, sending smaller batch sizes. And that's not the most efficient way of working for TigerBeetle. So there's a trade-off here. We have those two implemented. We have been testing this one, and we will keep on testing to get the best possible performance from TigerBeetle. So now over to Jason to explain you how this all works from the liquidity perspective.
Thank you, Pedro. think, yeah, thanks for that. You can jump over to the next slide. Yeah, you might as well. Okay, so yeah, what we're going to talk about is two changes. The actual changes to the implementation that you see here is work in progress, but it's, yeah, so let me start taking everyone through it. So what we have on the left-hand side is the accounts and balances bounded context, as Pedro explained, and on the right-hand side, we have the TigerBeetle cluster. The very first thing, and this is very much centered on the liquidity check. So there's a lot happening outside of this that's not shown in the flow, but this is, yeah, very focused on simply the liquidity check and how we are improving the performance and the chattiness of the liquidity check operation. So what we're doing today is we're doing an account lookup in TigerBeetle to make sure that we've got the most recent balances, because the liquidity check depends on a whole list of balances, like the pending balances, as well as the position and liquidity balances. So upfront, we get all the balances, and then the application logic for accounts and balances is responsible for doing the check that we see. You know, the steps are not numbered, but if we see there internally, if I have to talk about the step that we're in right now, which is that liquidity check that Pedro is indicating, and then based on that, the application can go one of two ways. It can obviously fail when it sees that the balance has been exceeded, or that the liquidity check has failed, and then indicate to the caller to say, sorry, you're out of balance, you need to top up, or you need to do a deposit. And in the happy path below, it would perform the second step if the green light is given, to go and create those transfers in TigerBeetle. So we've got two calls that's being made to TigerBeetle here, 1 and 2. Which is not the most effective way of doing this. After spending time with the TigerBeetle team, it became very clear that the best way of doing this would actually be in a more deterministic manner, and also creating less traffic, where instead of, and more safety, because as we've seen in the previous example, we do a lookup and then do the check outside of TigerBeetle, but it's actually possible for us to do the check within TigerBeetle. So in that scenario, which is the one that's currently work in progress, the implementation as it stands would might still change, but yeah, it's current work in progress. So we'll go into more detail over the next slides. But from a high level, what we're doing now is not have a separation between, yeah, you will always just have one single call, and that is what you see over here. In comparison with the create transfers from the previous flow, is you'll simply take a set of transfers. So each prepare and fulfill in Mojaloop actually has a lot more transfers that's been created in TigerBeetle. Well, not a lot more, but there's more. We then create the transfers, and we do that by introducing control accounts where we would create the transfer, and the actual accounts, as Pedro mentioned earlier, those account addresses are all cached. So there's no need to do lookups to the actual accounts anymore, number one. And we don't need to pull the balances into the accounts and balances bounded context in order to do the checks for the liquidity check. So now we're doing all of those operations in a single step, even though TigerBeetle needs to do the debits can't exceed credits check along with creating the actual transfers. But now it's all sitting within TigerBeetle. So when you create the transfers, it will do the liquidity check within TigerBeetle, and then and this is achieved via doing link transfers. And based on the outcome of that, you will either have it all went well, or some of them didn't go well. But the good news is that we've rolled back all of your changes effectively, and then we simply report the outcome of that creating of the transfers back to the caller. So you can see, if you could take a step back again, Pedro, you can see that the flow is, sorry, to the previous slide. If you compare it to, it's a lot more straightforward now, and it's a single operation that we're doing straight into TigerBeetle, which is, yeah, we still need to record all of the differences in performance, but it's obvious that the performance should be much better. Okay, if we go forward again. So the way, yeah, so this is the new one. The next slide then is where we go into a little bit more detail. If anyone is interested, we can always schedule separate sessions where we talk about this in more detail. And there might be feedback from some of the Mojaloop community members on how exactly all of this is occurring. But this is just a shortened version of what's actually happening. So the very first step there, we can see that the actual check is being performed on the control account for the payer. And if that passes, then you've got it. Well, sorry, if it passes, you always will be sending the exact same set of transfers for the prepare step. So this is our prepare step in Mojaloop. And the first two steps there are to do the liquidity check and against the control account, which will have the balances for both the liquidity and the position. You then perform the check and then this for the first transfer. And if you'll also notice here with the flags is that all those transfers are actually linked, so they will all pass or fail together. So the first one you set on the control account that you will not have debit exceeds credits. Therefore, if you overcharge the control account, you know that you've just exceeded your cap. That's basically what's happening here. And then we create that for the first transfer. So we know if the first transfer passes, we're good to go. We can proceed with charging the account or the payer and the debiting the payer and crediting the payee. We then create another transfer to cancel out that pending transfer that we created in the first place. And then following that is where we do the standard flow of using the hub account along with the payer position and doing the reservation for the prepare on the payer account. So we've got a successful prepare here. It's within our limits. Okay, next step, Pedro, please, next slide. So once we have the fulfill successful, I think there's a bit of a delay. Let's just see. Oh, sorry, you're already on the fulfill. So the next step here is where we're actually doing the fulfill. And what's basically happening here is we're canceling out the pending, also link transfers. We're canceling out the pending transfer from the prepare. And then the final two transfers at the bottom is where we're doing the actual debit and credit on the payer and payee's accounts. So this is happy path. And this is in a summary of how we're achieving that. And given straight from the TigerBeetle client, if you remember the slide of the flow, it will indicate to us that either the first transfer succeeded or it failed. And right there, we know, great, all success or failure. Now, in the case of, like Pedro mentioned, we do have the cancel reservation command that we support that's going to be canceling or avoiding the actual reservation from the VNext side of things. But built in TigerBeetle, there's also a timeout. So our accounts and balances will, if we don't get the fulfillment in time, it will time out anyway, and that makes sure that everything is worked out perfectly. And the next step is in the case of so there we've got that working. You can go to the next slide, Pedro. Okay, and then we've got the other case here of what we just mentioned, that if you have in the prepare step where you're doing the liquidity check, the first transfer fails, you can see that we're still sending in 4 transfers, but because the first one failed and the transfers are all linked together, the rest will be ignored and nothing would have happened and we get our failure. That's it, yes. So you want to cover the next steps, Pedro?
Yeah, well, thank you, Jason. There's a lot in there to unpack, so I'm assuming people will have questions. But this strategy was devised between Jason, myself, and also the TigerBeetle team. Well, actually, they were the proponents of this strategy for the accounts, so that we don't have to use lookups, which is the most efficient way of doing this from TigerBeetle. So if anyone is interested, as Jason was saying, it's probably best that we schedule a deep dive session on this and even bring the TigerBeetle guys so that they can explain all of the internals and why this is more efficient on TigerBeetle's side. So yeah, next steps, 2 very quick next steps. We need to execute the test of the no lookup strategy, which is this one that Jason just described, with a single client approach. And then we need to compare the performance. We have the expectation that it's going to give us a lot more performance, but which is how TigerBeetle is designed. We need to test it. So we now need to get the numbers and characterize exactly how it works. And the other one is we need to wrap up this whole exercise by executing a load test in a production-ready cluster of TigerBeetle and also vNext. So we need to put everything packaged together in a cluster as anyone who adopts this is going to use, and then load test it and characterize the performance of this system, and also do all of the tests, the integration tests, to see if it fails, how it fails, making sure that no part of this is left in a bad state. So that's it. Jason, you want to do this one?
Well, yeah, obviously just thank you to Hui and Rafael and King, and for the whole TigerBeetle team. It's like I meant, like Pedro and me mentioned, it's work in progress, and we might get even more optimizations from what you've seen today. So yeah, it's I'm very excited to look at the end result for what the outcome is going to be. So yeah, looking forward.